now it's determinant of 3 by 3. So there are actually two ways or two methods to find determinant of 3 by 3 matrix. So this is the first method when we use definition. So if it's given A is equals to 3 by 3 matrix with element A11, A12 up to A33. So the determinant is given by this one, where we add the first two column here. Okay, 1, 2 to be here, 1, 2, and then we take the diagonal to the right, from left to right. Okay, this one multiply A11 multiply by A22 multiply by A33 plus A12 multiply by A23 multiply by A31. Okay, plus A13 times A21 times A32. Okay, we have the first part minus. Okay, the second part is where the diagonal from right to left. Okay, this one. Okay, multiply plus. Okay, this one plus the diagonal. This one multiply. And also this one. Okay, here. So we will obtain the determinant. This is the one method to find determinant of 3 by 3 matrix. So let us try to do this example. You want to find the determinant. So first we write the matrix. So A, determinant of A is equals to -4, 6, 3, 7, -2, 8, 1, 0, -5. And then we add the first two column. -4 we rewrite again. 6, -2, 0. We add it here. And then we will use the formula or the definition. So this one, okay, times plus this one plus this one. Okay, so determinant of A is equals to -4 times -2 times -5 plus 6 times 8 times 1 plus 3 times 7 times 0. Okay, minus. Now the second part. Okay, I'll use green color here. Okay, this one, and this one. So it will be 1 times -2 times 3 plus 0 times 8 times -4 plus -5 times 7 times 6. Okay, now we can simplify it. So the one with 0 will be 0 because it multiplied by 0. So we're just left with -4 times -2 times -5. So it will be, the answer is -40. 6 times 8 is 48. Okay, minus, okay, this one 1 -6, and here is -210. So just left with 8 minus -216, which is equals to 224. So this is the answer for determinant of A, which is a 3 by 3 matrix. So that's it, the first method. Okay, the second method is where we want to find determinant of 3 by 3 matrix by using the concept of minors and cofactors. So basically, to find cofactor, we need to find minor. Okay. So what is a minor actually? So I'll go straight away. Okay, if you want to find M11, for example, M11, so we will delete row 1 and column 1 and row 1. Okay, never mind, I show on the example. Okay, let A is equals to this one. So if you want to find M11, so we'll delete this row 1 and column 1. So we'll find the determinant of the matrix left. If we want to find M12, so meaning is row 1, column 2. So we will find the determinant of the matrix left after we delete the row and column. So my cofactor is the minor where we use this formula to find it. Okay. Okay, never mind. We look at the example now. So M11, calculate the minor and cofactor. First, M11. So here is row 1, here is column 1. So M11 is equals to the determinant of negative 6, 5, 2, 0. So you have learned on how to find determinant of 2 by 2 matrix, right? So it's 0 minus 10 is equals to negative 10. So M is equals to negative 10. How about C? M1. How about C11? So we'll use this formula. So it's equals to negative 1. Ij here is 1 plus 1 because A is number of row, J is number of column of the minor. Okay. So it will be positive 1, right? Because negative 1 power 2 is 1. So we're left with negative 10. That's it. Okay, next is M23. Okay, this is number 1. Number 2, we want to find M23. So where is row 2? Row 2 is here, column 3 is here. So the matrix that we want to find the determinant is negative 2, 0, negative 1, 2. So we want to find the determinant of this matrix. So it will be negative 4 minus 0, which is equals to the negative 4. So M23 is equals to negative 4. What is C23? C23, we follow the formula negative 1, 2 plus 3. Okay, the minor is equals to negative 4. So negative 1 power odd number will be negative. 2 plus 3 is 5. So negative 1 power 5 is negative 1. So negative 4 is equals to 4. So that's it. To find cofactor, you always need to find the minor first. To find the minor, we delete the particular row and column that we want to find. Okay, to find cofactor, we use the formula negative 1 power I plus j multiplied by the minor. So let us try this example. Find all the minors and cofactors of A. So it's given A here, a 3 by 3 matrix. So you need to find all minors and cofactor. So let us start with M11. Okay, M11 you need to delete this row and column. So it is negative 1, 2, 0, 1. Okay. M12 and 1, 2, row 1, column 2. So it is 3, 2, 4, 1. And then row 1, column 3. So M13 is equals to 3, negative 1, 4, 0. And then M 2, 1. Row 2, column 1. So it's 2, 1, 0, 1. And then M22. We will have it equals to row 2, column 2 here. We delete the row. So 0, 1, 4, 1. Okay, next is M23. M23, row 2, column 3. We delete. So 0, 2, 4, 0. We left it with that. And then M31. Row 1, row 3, column 1. So it is 2, 1, negative 1, 2. And then row 3, column 2, M32. So it's 0, 1, 3, 2. And then M3, column 3, which is M33. So the answer is 0, 2, 3, negative 1. Okay, so let us find determinant of all of these matrices. So here is negative 1 minus 0 is negative 1. Here is 3 minus 3 minus 8 is negative 5. Here is 0 minus negative 4, which is 4. And here is 2 minus 0, so it's 2. Here is 0 minus negative 4, which is equals to negative 4. Continue next. 0 minus 8 is negative 8. This one. 4 minus negative 1, it should be 5. Here 0 minus 3 should be negative 3. And last one, negative 0 minus 6. So it should be negative 6. See, so we obtain all the minors. So now we can write our minor. So M is equals to negative 1, negative 5, 4, 2, negative 4, negative 8, 5, negative 3, negative 6. So we can write in matrix form. So to find cofactor, okay, see, actually there's a shortcut like this: positive, negative, positive, negative, positive, negative, positive, negative, positive. So you have to calculate using formula, because when you calculate using formula you still get the same thing. So meaning, okay, here M is negative 1, right? But when you look here, it's positive, so nothing will change. So it will be negative 1 there. So still negative 1. Here negative 5. Negative 5 here. But you see the symbol here is negative. So negative times negative 5. So negative 1 times negative 5 will be positive 5. So that's why we have 5 here. Okay, next 4 here. We look here, is position here, right? At position row 1, column 3. Okay, so it's positive. So we maintain the value. So it's still 4. Okay, the same thing for 2 here. Position is row 2, column 1. So it's here. Right? So it's negative. So you must put negative. You multiply by the negative of the original minor. Okay, negative 2. So if it's negative 2 here, it will be positive 2. Next is negative 4. Here is negative 8. So it's negative here, so it's become 8. 5 here is positive, so 5. Here is negative 3. Negative here, so it become positive 3. And here is negative 6. so negative with positive, so it doesn't change the value. So if I want to rewrite again, C is equals to -1, 5, 4, -2, -4, 8, and 5, 3, -6. Okay, that's it. So this is the answer for minor, this is the answer for cofactor. So next is to find determinant of 3 by 3 by using cofactors. So minors and cofactors. So we have known what is the minor and cofactor, how to find minors and cofactor. So now we can find determinant. Okay, to find determinant of 3 by 3 matrix, okay, if Cij is a cofactor of matrix A, then the determinant of matrix A can be obtained by expanding along the ith row, this one, or expanding along the jth column. Okay, you can use one column or one row to find the determinant. For example, if you have A is equals to A, B, C, D, E, F, G, H, I, J. Okay, for example, so if you know what is, you can use row 1, okay, to find the determinant. Okay, I better write in general form. So it's A11, A12, A13, A21, A22, A23, A31, A32, A33. Right? So if you want to use row 1, so meaning your determinant A is equals to, you follow this one, A11 C11 plus A12 C12 plus A13 C13. So meaning you need to find the cofactor first. Okay, then only you will multiply by the element inside the matrix. Okay, if you want to find the determinant along the column, for example, we have here column 1, right? Column 1, so A11 C11 plus A21 C21 plus A31 times C31. So you need to find this cofactor. Okay, you can use any row or any column. You can, whether you want to use row 2 also can, row 3 also can, column 2 also can, column 3 also can, because you will still get the same answer. So this is the basic formula. So you need to find the cofactor by using the method that we have learned before, and then you substitute in this formula. So only 3 cofactors is needed to find a particular determinant. So now let us try to do this exercise, how to find determinant by using minors and cofactor. So let us choose row 1. Okay, I want to choose row 1 to find the determinant. So I need to find what is the cofactor of these 3 elements. Okay, so I find M11. So M11 is this one, -2, 8, 0, -5. M12, this one, 7, 8, 1, -5. M13, Okay, row 1, column 3. So it will be 7, -2, 1, and 0. So now you find what is the value of m. Okay, so 10 minus 0 is 10. Here is -35 minus 8. So it should be -43. Here is 0 minus -2 should be 2. So what is C11? So C11, so if we look at the tips I've given previously, so it's positive, negative, positive, right? So C11, so it doesn't change, is equals to M11, so it's 10. C12 is equals to negative of M12, so it's 43. And C13 is equals to positive of M13, so it's 2. Okay, so it's there now, so we can substitute in the formula. A is equals to A11 C11 plus A12 C12 plus A13 C13. So A11 is this value. Okay, we take this value. The first one is A11 is -4, C11 is 10, plus A12 is 6, C12 is 43, plus A13 is 3, times C13 is 2. So the final answer that we will get is, okay, -40 plus 258 plus 6. So we will get is equals to 224. That's it. Okay, you can use another column or row. You can use this column, this row. Okay, it doesn't matter. In this case, I choose row 1 because it's not stated. If it's stated to use which row or column, you need to use it. Okay, I repeat again. This one, what does it mean? The cofactor is equals to, okay, positive of M11, negative of M12, positive of M13. Okay, it's not that here should be positive value, here should be negative value. No, it's the negative of M11, it's positive of M13. Okay, next we have M21 should be negative because it's negative, positive, negative, positive, negative, positive. And then positive of M22, negative of M23, positive of M31, negative of M32, and positive of M33, like that. Okay, so when you get these three value, okay, you need to find the cofactor. Okay, the tips is here. Alright, so you have to use the formula, but it's okay if you still want to use this formula, it doesn't matter. So here are some properties of determinant. Okay, you can go through one by one. So that's it for determinant of 3 by 3 matrix. Thank you. So next is the adjoint of 3 by 3 matrix. Let A is an n by n matrix, a square matrix, then the transpose of the matrix of cofactors A is called the matrix adjoint to A. So meaning when we have the cofactor, we transpose it, we will get the adjoint. So for example here we have to compute adjoint A. Okay, the notation is like this: ADG bracket A. So if A is given like this, 3 by 3, so we need to find the cofactor first. So to find cofactor, we need to find the minor. So what is M11? Okay, M11 will be 10 minus 0, M12, M13. You need to find everything. M21, M22, M23. Okay, and then M31. Okay, first settle this one first. So M12 will be negative 35 minus 8, right? And then M13 will be 0 minus negative 2. So let us find the answer together. So next M21 will be negative 30 minus 0. Okay, and then M22 it will be negative 20 minus 3, right? And M23 it will be 0 minus 6. Okay, so where do I have to write this again? Here, M31, M32, M33. So M31 row 3 column 1, so it will be 48 minus negative 6, right? And then M32 it will be negative 32 minus 21, and M33 is 8 minus 42. Yeah, so what's the answer here? Here is 10, and then 43, here is 2, here is negative 30, here is 17, here is negative 6, this is 30, and then we have 48 plus 6, which is equals to 54. Here is negative 53, and last one it is negative 34. So your M here is equals to, okay, we write again the M, 10, 43, 2, negative 30, 17, negative 6. Here is 54, negative 53, and negative 34. So the C, we follow positive, negative, positive, negative, positive, negative, positive, negative, positive. So positive of 10 is 10, negative of 43 is negative 43, positive of 2 is 2, negative, here is negative, sorry, here is negative here, so it's positive here. Okay, we continue. So negative 30, so it's become positive 30, and then 17, negative of negative 6 is 6, and then positive of 54 is 54, negative of negative 53 is 53, and positive of negative 34 is negative 34. Okay, so this is the cofactor that we want. Okay, so the adjoint is actually like this. Okay, adjoint of A is equals to the C transpose. So it's equals to, you just transpose it, 10, 30, 54. I hope you still remember how to transpose a matrix. It's very simple. We just change the row become column, and the column becomes row. So this is the adjoint that we want. Okay, that's it. So this is exercise. I leave it to you to do it. Okay, This is the final answer. I hope you can get it correctly. Okay, good luck.